lesson is going to be about balancing chemical equations. And so the problem says hexane combusts in excess air to form carbon dioxide and water. What is the balanced chemical equation for this reaction? So in order to start this problem, we need to determine the chemical formulas for each of our reactants and products. So I have listed here our reactants, which are hexane and air, and our products, which are carbon dioxide and water. And so hexane follows the standard naming procedures for organic structures, and so the hex tells us that we have 6 carbons, and the ane tells us that there are only single bonds present. So this tells us that hexane's formula is going to be C6H14. And air, for the purposes of this problem, we're going to ignore all of the extra components of air and only consider oxygen, which is a diatomic gas. And so air, which is just oxygen, will be O2. And then carbon dioxide, we know will have 1 carbon and 2 oxygen to give us CO2, and water is just H2O. So now that we have the chemical formulas of all of these, we can write out our general equation, leaving space in front of each of them so that we can fill in the coefficients as we go. So we have blank C6H14 plus blank O2 yields blank CO2 plus blank H2O. And so now we're going to want to make a list of the atomic species on each side of our equation and fill in the amounts of atoms on each side so that we can balance the equation. And so on each side we have a carbon, a hydrogen, and an oxygen. So if we just look at the left side first, we have carbon, hydrogen, oxygen, and we have a total number of 6 carbons, and then we have 14 hydrogens and 2 oxygens. Now if we do the same thing on the right hand side, we have carbon, hydrogen, and oxygen. We see that we only have 1 carbon, and then we have 2 hydrogen and 3 oxygen. So now, based on these numbers that we just wrote down, we can determine the ratios. So our carbon ratio is going to be 6 to 1. And then our hydrogen ratio will be 14 to 2. And our oxygen ratio is going to be 2 to 3. So now that we have these ratios, we're ready to determine our coefficients. And so we're going to want to find carbon and hydrogen first, because carbon and hydrogen are only present in 1 molecule on each side of the equation, so they're going to be the easiest to balance. So we will do those first. So now, based on the carbon ratio, which is 6 to 1 we just said, if we have one hexane molecule, that means we need to have 6 CO2 molecules in order for that to be balanced. And then using our hydrogen ratio of 14:2, again, if we have one hexane, we're going to need to have 7 H2O molecules in order for our hydrogens to be balanced. So now we can do a little check. So we said we have one hexane, which is C6H14, plus blank O2 yields 6 CO2 plus 7 H2O. And so if we write out our atomic species for each side again to check, we see that we still have 6 carbons on the left-hand side and 14 hydrogens. And now on the right-hand side, we see that we have 6 carbons and 14 hydrogens. So now we're ready to try to balance our oxygen species. And so on the right-hand side, we have a total of 19 oxygen. And so to get 19 oxygen on our left-hand side, we need a total of 9.5 as our coefficient in order to get that 19 oxygen, because the value of our oxygens directly relates to that coefficient. So, but that's not going to work because we cannot use half numbers. So we cannot use half numbers as coefficients. So we're going to double all of our other coefficients in order to get rid of this half. And so once we double everything, we can recheck this. So now we're going to have 2 C6H14 plus the 9.5 was our original coefficient, times 2 will give us 19 O2, yields 12 CO2 plus 14 H2O. So let's go ahead and check each species again to see if we have it fully balanced. So now we have a total of 12 carbons on the left, and then we have 28 hydrogens, and now we have 38 oxygens on the left. And on the right-hand side, we have 12 carbons, 28 total hydrogens, and 38 total oxygens. So as you can see, each of our species is fully balanced on each side, so this is our fully balanced chemical equation.